Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. And our guest today is Professor Jordi Cabot, who is the head of software engineering RDI unit at LIST, so Luxembourg Institute of Science and Technology, and affiliate professor at the University of Luxembourg. Jordi has been here less than a year, and we got him thanks to the FNR Pearl opportunity. Jordi, thank you so much for coming today.
Thanks for inviting me.
Okay, so I said head of software engineering. I have to say I have quite a lot of friends who are IT specialists. So I said okay, tell me, what is software engineering? So they told me a few different definitions, and I'm very curious what you will say. What is it, actually?
It's the process of building software. I think that the key element is the word engineering. Because people tend to think that software development is about a person locked in a room writing code, and it's not really about that, right? It's really about following certain practices, good practices based on science and processes to produce high quality software. And in our field, we need to basically convince people that you need to follow these well-defined and well-known practices to reach this high quality software, instead of just having ad hoc development practices and style, right?
You need to convince people. So probably that's a difficult process.
Software engineering is a very young field, right? Software exists since 50, but now it's a bit older than that, 80 years maybe. Software engineering as a term was coined in the end of the 60s, so 68. For people that build bridges, build roads, even architects, nobody discusses the need to design the bridge before building it, test, simulate that the bridge is going to resist the strength of the wind, the strength of the water, the erosion, and do all this before actually starting building the bridge itself. But in software, there was this feeling that there was something that you could do on your own, just directly programming without thinking too much and then just iterating on that. And that works if your software you're building is really a toy application, but not what we're talking about, critical systems that are managing hospital or medical devices. So we need to as of today, need to somehow embed, even in our own community, the need to make sure that you follow a certain number of standard practices when building software.
So you can't just sit down and start coding.
You can, but then the result, I would not really trust my life on that software.
So convincing people, convince me right now, because my feeling is that we talk more about it, because I do see, more specialists in the field and whatever, but I also have a feeling that the software is getting worse. So what's going on with the convincing?
Because you are asking more and more out of the software that you are using every day. Okay, not so long ago, we had your desktop computer and you had to install the software there, and that was the only place where you were using that software. Then you wanted it on the web. Then you wanted it on your mobile device. Now you want to talk to your software with chatbots. So you're asking more and more things, even controlling your house with sensors and domotic operation, right? So you're asking a lot of things about the software, which means that the software is getting worse. It's your feeling in the sense that it has more flaws, has more errors, but because it's getting much more complex than before. And of course, this additional level of complexity is something that, again, with engineering practices that need to be adapted to these new types of software, we need to be able to cope with that.
I read somewhere that you said that the software development is in a permanent state of crisis. This is what you meant exactly? That it's growing out of proportions and we're not really controlling the processes, or you meant something else?
It's exactly that. It's the fact that we know how to build software, but every time that we somehow settle down on a way to build software, there's something that disrupts the software industry. Again, because there's new types of requirements, again, the mobile, cyber physical systems, artificial intelligence. And then we are forced to relearn how to build software for these new domains and these new environments. So this means that we're always behind the trends. And there's a period of time in which basically we are still learning and we make a lot of mistakes. And that's this permanent state of crisis.
And is it also because they're just specialists in the field, all the coders, all the programmers are so much required right now that the people who actually take care of the programming are people who might not have that thorough experience of coding and programming? Is that also the problem or not?
I think that the two are true in the sense that there's always a need for more programmers. It's a very well-paid profession if you are good, But still, it's so much of our world is based on software. There's still increasing demand. So on the one hand, we have this shortage of programmers, but then even for those programmers that are already in the market, they also need to reinvent themselves every time. And that's more difficult because you can be a very good programmer for mobile applications, but then you are not an expert on AI. So when the request for the new software is about adding a chatbot to your application, you are maybe a great programmer for one domain, but a terrible one for this new domain. So there's this, again, this kind of a constant struggle, let's say, to find good programmers for that type of application that you need to build.
This is a very important point that you mentioned, I think, because the tendency of people who don't know anything about programming or software is that, okay, here you're some IT specialist, so like, I don't know, fix my computer, or then exactly like, why don't you know more about AI?
You know, my wife is a biologist, so she always gets angry when I ask her, what's the name of this flower, right? So I don't know, I'm a genetic specialist, I mean, I don't know about flowers. So it's the same for her, right? So from the outside point of view, it may look that programming is just one thing. Probably when you start a degree in computer science, you go there thinking that you are going to be a programmer. But really, computer science and software engineering is really a lot of different things, from databases to AI to deployments to optimizations to scalability. So we are not the same.
I'm going to ask a tricky question. I'm very curious what you're going to say to this, because you just mentioned that you study computer science. Do we actually need to study it to be good programmers or software developers?
Do you need to study to be a good doctor?
Yes.
So it's the same. Again, you need to study computational thinking, which to me basically is something that everybody should study. It's a capacity to think in a computational way, in the sense that it's a capacity of being able to decompose problem in different steps and find a solution by combining these steps, and probably it's useful for everybody. So you need to learn all the basics. You need to learn a little bit about complexity so that you can predict whether the solution you are building is not going to scale, because maybe it's an exponential complexity and it's going to be out of hands quite rapidly. You need to learn the basics of modeling, which is one of my specialties, which is the capability to abstract from the technical irrelevant details of the domain to really get to the core elements and use those core elements to build a solution, again, because you are focusing just on the important part. So you need all these skills. And I think that the best that you get out of computer science is these capabilities, not being able to program in one specific language. Because the language, when I started with Pascal, and then I moved to C. But even C, when I went out, was already out of fashion, because at the time Java was the one getting popular. Of course, now even Java is still very useful. It's a great language. Don't get me wrong. I love Java. But if you talk about Java with, say, younger people, they could look at you and say, you are legacy, right? So you're kind of old guy. Now it's Python or even, Rust or other languages. So I think that the important in computer science is to learn the concepts and the skills more than the syntaxes and languages.
Before I ask you something more about what you said, I just thought that maybe this is the right moment to ask our listeners the pub quiz question that you prepared. And listeners, remember, of course, the usual process is that you hear the question now, but the answer will be only at the end of the podcast. So don't forget to listen to the whole thing.
Probably when you think of a car, you don't think of a car as a software application. It's kind of something more physical, right? It's mechanical, it's hardware. But it turns out that inside the car, inside your car, there's a lot of software running. So my question would be, can you guess how many lines of code run within your car?
I love the question and I don't know the answer, so I'll be waiting for the result, the answer at the very end as well. And I would assume that probably a lot, right? But it's great you mentioned line of code, because I know there are always those discussions of someone has a beautiful code and someone doesn't have a beautiful code. So line of code is just one command, let's say. Can I call it like that? Or not?
It's one instruction. Yeah.
One instruction.
Yes.
Okay. So yes, just for those people who don't know about it. And I don't want to get into the beauty, because I think we'll get some people already ignited with the types of languages and which are good, which are not. Then if we start talking about what it means to be beautiful when you code, that's going to be probably another hour to discuss it. But I wanted to ask something else. So I also know that, okay, you specialize in modeling, but whenever you write about your methods and your research, you also talk about smart software. And that got me a bit lost, because I thought all software was smart, or it means something particular. What is it actually?
When I talk about the smart software, I basically mean software that embeds intelligent components in it. And I think typically a good example is thinking about an e-commerce application, right? Just a website where you can buy product. In a classical approach, you have just a website, a database, you could buy the products and pay. But in a kind of the new generation of e-commerce sites, they all want to have at least a chatbot so that the user can talk with the software. And that's already an example of an intelligent component in the front end, right? Because this component has to be able to understand natural language and understand the ambiguities of natural language and then process your request. But you also want that then when you add a product in the shopping cart, the application suggests you different products that could be related to the one that you just bought, because as an owner of the e-commerce application, you want people to buy a lot. So this process of recommending products based on previous historical purchases is also another intelligent component that will be able to discover trends in the purchases processes of people to suggest what could be the most optimal other products for you to buy, right? So there's a lot of intelligence embedded in both the front end and the back end of the software. So any kind of software product today has to be intelligent to interact better with the user. And that's what I call a smart system.
Okay, I understand that, but I have to ask one more question from what you said. You said it twice, so all the more need to explain it. You said front end and back end, and I think not everyone knows what it means.
So the front end is basically the part of the software that interfaces with you. So it could be just, again, the web page or a chatbot or a voice bot. And the back end are basically the services that are going to be executed to perform the action that you requested the software to build.
So when I see a job ad for a front-end developer, that's a person that will be taking care of the user interface more. And then back-end, it's the stuff that we don't see as customers.
It's a business logic, we call, right? It's really the calculation of the offer, the calculation of the prices, all the heavy stuff, let's say, that is not nice to see. That's why it's in the back-end.
Okay, but still has to be beautiful, as we already said. At least you have to try. If someone takes over, to know what you're doing.
It has to be beautiful for the next programmer taking over the project, yes.
Exactly. Okay, so in the definition you mentioned exactly front-end, back-end, but also you mentioned the chatbots. I think it's a moment to move to that because that's also one of the research focuses of yours, right? And when we talk about chatbots, what are we actually talking about?
A chatbot is a type of interface that typically could be alone or complementing a graphical interface that we are all used to. And inside the chatbot, basically what you define is a set of intentions that the user of your application could actually ask to do. And then the chatbot needs to be able to match the user request or the text that the user writes or the voice command to one of these intentions that are predefined in the bot. Right? And then basically the bot will then call the backend service to implement or to perform the action that you ask the bot to do for you. So basically the core of the chatbot is a natural language engine that is able to understand the user conversation and transform that into something meaningful for the bot to react and respond.
Natural language, that means the language we are using as human beings,
Exactly.
Not the programming language.
Exactly.
Okay. I think today this episode is going to be full of those things we really hear a lot, right? But people just don't know what it really means if you don't work in the business.
Chatbots, you can see it as just a better way to talk with the software, right? Because instead of having to move your mouse around and knowing where to click or where to drag and drop, it's really you talk as you would talk with a person. And then it's the job of the chatbot to really understand what you're saying and try to get some meaningful semantics out of it.
Yes, and I think this is also a subject that is very strong right now because my first experience with chatbots were basically close window. I don't want you there because I just felt
I want to talk with a human, right?
Yes, it just felt so bad, right? And now we have, of course, the thing that everyone talks about, so ChatGPT and all the other chatbots that are so advanced in comparison, right? So everyone suddenly got very excited about it.
Yes, but there's a lot of dangers there as well, right? Because in a classical chatbot is the chatbot designer who defines the list of questions, the list of intent, as we said before, that the chatbot should recognize and respond to. And then the response, basically, is coded as part of the chatbot. So it's a chatbot designer who basically says what you need to answer to this question. When you go to large language model like ChatGPT, you have huge flexibility. You don't need to predefine all the potential questions. You just take the question from the user and send it to this large language model, and you get the answer and give it back to the user. So it's amazing. Amazing, but you have no control on what the chatbot understands and no control on the quality of the answer. So again, it's a trade-off between the flexibility and the risk of the chatbot hallucinating, which is the technical word that is used to describe this situation.
Hallucinating?
You say that the ChatGPT hallucinates because it just invented a response that is completely made up by the bot, but you don't know it.
You said you have no control of the quality of the response, but weren't there people who were kind of saying, yes, this is a good answer? Exactly. So there was some control.
Yeah, there's a lot of attempts to control. And just saying that you cannot be 100% sure that the answer is going to be correct. So again, it depends a lot on your scenario. So if you will go back to the e-commerce system, you may want to make sure that some of the questions are fixed. Because if they ask you whether you ship to France, you for sure want to make sure that the answer is correct. Otherwise, you have a problem. So you have what we do in our team is that basically we say, okay, part of the question answers are fixed, kind of a classical approach. And for those, we control. And then for others, like is vitamin C good for health? Maybe that's just too open. So we just send it to ChatGPT and just give back the answer, telling the user that this answer is coming from a large language model.
So what you're saying, next time I go to buy something and I ask the chatbot some completely unrelated question, it will actually answer something.
It could. Depends on the chatbot design, whether they want to open or not this door to ChatGPT.
Okay, sounds cool. In a way, I don't know, for some people who are looking for answers where they shouldn't be looking for them, but fair enough.
Well, again, when you train the bot on a specific set of answer, there's some effort involved in that. So again, you cannot just pre-train a bot with thousands of questions because it would be too expensive. So again, at some point you cut the manual approach and then you go to ChatGPT for the rest.
It just reminds me, recently you were writing something about clients not wanting to really control that kind of input, let's say. So what's the problem there?
No, what clients want is not to do the work, right? So the clients want the bot to learn magically from just interactions with the users. And I can understand that. So they say, okay, the bot should be able to learn from the interactions and just every time there's a new question, it should add this question to the list of questions that the bot manages so that the next user gets the right answer. Which again, I understand, but to me, this always needs to be supervised because otherwise the bot would learn a lot of things that should not learn. So a good known metric for that, which is time to sex, which basically means that if you give an interface to anybody, it would take really, really a short time for that person to start asking sex-related questions or drawing sex-related things. So you have to be careful. Your users are a dangerous species of animal, and you want to make sure that you supervise what they say, what they do with your software.
It just makes me realize that I must be very tame because I've never asked such a question in my life, nor have I, just asked a question to a bot that was not related to the reason I was on a website.
Yeah, you may be the exception, but when, Alexa and Siri, all these devices started, typical question, can you be my girlfriend? And, I'd say more spicy questions were one of the first things everybody was asking.
Okay, cool. Good to know. Different parallel worlds that I'm not aware of. But yes, let's say I don't also use Siri. I have to say that it's not my thing, nor Alexa.
I call my mother-in-law with Alexa. Yeah.
Okay. Coming back to the chatbots, because we said already what they were, but you also developed something which is called the chatbot framework. So once again, in this podcast, we often talk about the definitions because, I just get your papers and then I'm like, okay, no, I don't get this and that and this as well. All right, explain to me. So first question, why chatbot framework? What do you mean with the framework?
So as I said, chatbot is a kind of complex piece of software because there's needs natural language processing, there's the interfacing, there's calling the services and all these things. We cannot expect users to do it themselves. We cannot even want programmers to have to develop a complete natural language engine every time they need to create a bot. So what we do is to follow a more low-code approach where basically we provide already a predefined set of components so that the programmer or the user even can just focus on defining the set of questions, an example for each question that the bot should understand, and we provide all the rest. So then you say, okay, I want this bot to be deployed on Telegram or to be deployed on this website. And basically our framework takes care of all the runtime execution of the bot, the connection with the Telegram platform, the exchange of messages, and so on.
Isn't that a library?
A framework includes several libraries. So to me, a library is more of a concrete set of functions for a specific task. A framework is basically a place that provides a much more than that. Like provides a complete environment for you.
I wonder whether you would get a job, because my friend told me that sometimes when you are actually applying for some programmer positions, you get such a question. What is the difference between a framework and a library?
To be honest, I'm pretty sure I would never get a job at Google or any of these places where they ask you of these kind of hardcore programming questions.
That's why you're a software engineer rather than a programmer.
Well, to me, I would like to see one of these Google exams or Facebook or whatever exams where the questions are really on the software engineering part, the methodological aspects, on the design of the software, not just, what's the best optimal data structure for a certain task that you will never really use in practice, right?
So why should it be there? You think the emphasis is not enough on that methodological part?
Yeah, I don't know why they focus so much on. I guess they think that people that have the capability to do a very optimal programming tasks then can grow up to being a manager. To me, that's not really the case. But who I am to contradict Google.
So let's leave it there and come back to the research, because you said, okay, that's why I'm here and not somewhere else. So I also wanted to understand for the chatbot framework, because you're developing still a new chatbot framework, but tell me, again, I have to mention the names you just mentioned. So there is Google, Dialogflow, there is Amazon Lex, all these chatbot frameworks that already exist. You have all the open source access to it. Why develop another one?
Well, how much money do you have?
Not much.
Then I would forget about all these solutions that basically they ask you to pay. Because what they offer is these natural language engines. But this means that every time the user writes something on your page, this something goes to their cloud, gets interpreted there, and basically they give you the response of what they understood from the text, which means that first you have to pay. Secondly, your data goes to them, which probably is not ideal in many scenarios where you will need to have some kind of privacy of the data. That's why we are building first an open source solution, so that it's up to you to deploy it even on your own server. It's up to you when you don't need to pay anything to use it. And also it's more open to configuration, right? Because in our case, basically, first, there are really very, very few open source chatbot solutions. There's Rasa, which is well known, but beyond Rasa, there's really not much.
So the Microsoft bot framework is not open source?
What is open source is the fact that they give you a library that you can use to build the bot. But then basically the execution of the bot ends up being calls to their cloud, which is how you pay, right?
Okay. So and Rasa does not do that?
Rasa... now I'm going to get criticized for that. I think it's less and less open source every time. So it started as an open source, and now I think they're pushing a lot the commercial version. But anyway, in our case, there are two things also that justify the creation of our bot framework. First, that it's going to be integrated in a low-code platform. So for us, a chatbot is just an element of the software system, and we want to be able to design the whole system together, not just have the main core component on one side and then somebody else doing the chatbot and then gluing it together, right? So that's why we wanted also to have this possibility to integrate. And then, I have to confess, all developers suffer from the not invented here syndrome. So this means that we always think that we can do better than the rest, and we all have this tendency of reinventing the wheel. So I guess part of that is true as well.
Okay. I got the answer I wanted to hear in a way, because I kind of noticed that too. You said low code. So tell me, because I kind of failed to grasp that. In a way, we're complaining that people don't think about this outside framework of things, about the methodology and about the engineering. And then we are trying to go for low-code solutions that probably mean that the barrier for people who are not very talented programmers or don't know all the languages is lower, right? Or that's not low-code. What is low-code? Because for me, I imagine, I don't know, what's the name? Scratch, yes. I imagine Scratch, low code in that sense. You have just blocks, or that's not low code, really.
That's no code, which is a more extreme version, right? So the low code is really, the goal is to write less code to do the same. I think that it's a kind of a marketing term for what it's always been known as kind of model-driven development and things like that, which basically the idea that you design the software and then you press a button and then you get the software generated for you. Right? Just kind of implementing the design. It's like if you had a 3D printer, now that it's popular, right? So you model the piece of plastic that you want to build, and then there's a button, and it creates for you. So that's the same of what we try to do with model-driven engineering. We just accept that it's really very, very difficult to generate 100% of the code because there are always those parts that need to be very optimal. So say we generate part of the code for you, most of the code, especially most of the boring code for you, and then you manually implement the rest. So this can be used even by developers themselves as a way to improve the productivity. Then we have the no code, which here is really targeting more the citizen developer or the non-technical end user, acknowledging that this person may need to develop some small applications, kind of plugging Excel with an email solution, things like that. And they don't have access to professional programmers, right? Because again, there's this shortage of high-skilled people, right? So it's a way to combine the two. In a low code, you can use it in a complex environment because basically the platform, you still need to design, to test the software. It's just that it accelerates the result. In no code, to me, it's more of a playground if you want to do your some things in-house that are just for your own usage.
But accelerating design is also just using libraries, because that's already doing a little bit of code for you. You just call it out and that's it.
Yeah.
That's what we're talking about in low code, or it's more complex than this?
In the low code, you don't really care about even the libraries because the platform that will generate the code will also plug the code with existing libraries as part of the process, right? So low code is where you focus on the design of the software. So you go to see the client, you understand the problem they have, you model that, the key elements of the domain of the business logic, how the business is working, and you define this with drawings and diagrams, which is again is easier to understand and to collaborate on. And then based on that design, you can tell ChatGPT or have some kind of code generator that implements that business logic for you.
And this also probably means that if the client changes their mind in 1 week, it's easier to change that too, right? It's not this kind of a thing. The client's talking to the developers do something, and then the client complains because they thought something else.
Indeed. And you can even, for people that really don't want to use low code because don't trust the quality of the generated code, you can at least use it as a prototyping tool where basically you talk with the client, you generate very quickly some prototype, you show the prototype to the client, and then you iterate on the prototype. And only once the client seems to be happy, if needed, again, that would not be my philosophy because I trust in the quality and that's why we are building one. But if needed, then you can basically throw away the prototype and just copy it in the real technological platform.
Why people would not trust this solution?
For the same reason we were mentioning before about the not invented here syndrome, right? So programmers tend to believe that any code that is not written by themselves is crap, right? So there's this kind of a tendency of fighting against going up in the abstraction level because you want to keep control. And when you're in a low-code platform, the part of the code that is generated, again, it's not your code. And you have to trust that it's well enough to do their job. It's fast enough to not be a problem, right? But I think we are getting there because, again, given the complexity of our systems, you actually need either you use low code or you depend a lot on libraries, as you said before. So I think that they understand that you cannot do everything right now.
One of the things personally I find very annoying is when someone gives me software and says like, I know how you will use it. You can't change anything. You don't get access to any code and just use it. And why do you complain if it doesn't work the way it should work? So in general, it gets me excited if I can just, do something with it, right? So I guess that's open source in the end, isn't it? Or what is it actually?
Basically, we all depend on open source, even if we don't realize it. I mean, most of the software that you have in your phone, in your car, or everywhere depends on open source libraries. So basically, open source to me is really and this is not even my definition, but it's kind of the digital infrastructure that powers our society. So this means that as a society, we need to care about open source because we always remember open source when there's some kind of failure of a well-known open source project, and then we say, this library generated all this vulnerability, and thousands of people are impacted. But then, how many people were actually paid to work on that? And typically, it's one amateur volunteer investing their free time on that. So I think that even from the government point of view, there should be really a lot of support for open source. And of course, when this software is generated from a research project, it should be open as well, right? There's this initiative of public money, public code that I think we should adopt as well.
Yeah, because if it's otherwise, as you're saying, volunteering work, I mean, I also understand that these people have to have a source of income. So I'm not surprised on this kind of introducing a paywall at a certain moment or switching from, a free whatever subscription to a paid one. You have to get the money.
But I think this is known as tragedy of the commons in other domains. And in fact, it's the reality of our society. So how many people read Wikipedia articles? Basically, everybody. How many people have ever modified or written a Wikipedia article? Basically, nobody, right? So there's this concept in which we all like to benefit from the work of the others, right? But we don't want to put the work. So it's a struggle, and we need to be kind of make people conscious and aware of what could be the implication if we do not support more the people that are actually doing the open source software.
How can we support them?
Money is an obvious option, because many of these people would be happy to be able to work full-time on that piece of software that they are maintaining, if they could. And there are different initiatives for that. Probably companies could be the ones paying this money. We don't need to do it as individuals. So there's WordPress, which is, of course, one of the most popular open source software in the world. The founder kind of promoted a 5 for the Future initiative, which the idea was that every company that was making a living out of WordPress, because you can make a living out of open source, so it's not an antagonism. You can promote open source and make a living out of it. So the founder of WordPress, with 5 for the Future, asked companies benefiting from WordPress to devote 5% of their manpower to support the WordPress open source core initiative.
But WordPress right now, I mean, it's also, there are so many plugins and stuff. If you want to have really a very advanced website, simple WordPress is not enough, is it?
It's not, which means that there's a lot of people that make a living by selling WordPress themes, WordPress plugins. And the message was that these people should also contribute partially to the core of the WordPress because they benefit from the work of the other people doing.
And are they contributing?
There's a lot of contributors. Of course, we are not close to the 5% by no means, but at least it was a way for him to, the number was not important. It was more of a raising awareness of, okay, it's not enough just to get the milk out of the cow, right? So you need to feed the cow as well.
Yes, totally. Talking of feeding the cow, we mentioned that before already, all this OpenAI and ChatGPT and whatever else. So as you are also present in many conferences nowadays, I also know that you do some public outreach and you talk to the youngsters about AI and everything. So, okay, are you excited about where we're going or actually more terrified right now?
I'm terribly excited.
Okay.
I'm terribly excited. I think it's amazing what we can do. It doesn't mean that we just need to trust blindly the result or not supervise a bit the direction we are going, right? I discovered last Saturday that my daughter, which is 12 years old, was using DALL-E to create images for a homework that she had. I had no idea. She was not really aware of what she was doing. Somebody had sent her the link. Now that it's integrated with Bing in Microsoft, it's very easy to use. And she was just creating images, but she's not aware of the ethical biases that could be behind these models. So could be affected by these biases. And so we need to teach people about the limitation and trade-off of this technology. We need to teach them about how to interpret the results. Again, not to trust what they say without fact-checking first. Be aware of the potential biases that can be in the result. And of course, we also need to be better at creating large language models that have better safe protection inside. But it's crazy what you can do with it.
It is. But once again, there is a lot about being able to prepare the right prompts and understand the results, understand the interpretation, and being able to work with it so it actually adjusts to what you want to get, so the result as well.
I mean, I use Copilot all the time, and it's very useful because my memory is not good enough to remember the exact syntax for every programming language I use. And again, every software project today uses a combination of Python, JavaScript, maybe some PHP or...
what is Copilot? Maybe not everyone knows.
Copilot is basically a coding assistant. So basically it's a tool that is embedded in your editor, in your programming editor, and basically will look at the code you're writing and suggest auto-completion, so suggest improvements. And you can even ask in the comments describing what you would like a certain piece of code to do, and he will try to basically create the piece of code for you. And again, I have mixed results. So in general, it works quite well because, again, I don't have the memory. So it kind of serves as a kind of a junior assistant that helps me with the basic stuff. Then you have surprises, sometimes good, sometimes bad. One of the bad is that I was writing a WordPress plugin, and it suggested me a kind of a certain WordPress function to do what I wanted to do. It looked very reasonable, so I trust him. I told her that function does not exist. It was invented by Copilot. Just by looking at all those that exist, Copilot assumed that this one would also exist, and it was not the case.
Yeah,
So,
it's this skilled use of syntax, right? And just kind of a chameleon way
Exactly,
of, yes. So you have to be intelligent enough to actually spot it as well. Okay, I guess you just ran it and it didn't work.
Was, and then I tried to find the documentation for the function to understand why it was not working, and I couldn't find the function.
But this is important, and it's also interesting what you said about this link that your daughter got. I guess it was not from a teacher, but one of her.
No,
exactly. Yes.
Never from a teacher.
Why never from a teacher?
But that's to me, it's a mistake. I mean, I would really make sure that starting at 11, 12 years old, they typically at the school, they get some kind of basic course on social media because they know that they started to have the phones and so on. So there's a course on harassment online and things like that. We need to do the same with AI because they will find and use all these type of solutions, and you want them to understand that they cannot just copy the response from ChatGPT as kind of an answer to the homework. So probably they should need some kind of, again, mandatory courses at the schools, and teachers should also prepare some kind of even tool sets that are more or less more safer than others, because there are some that are more kind of targeting children. They are not perfect, but at least they try to avoid certain topics, and we need to put in place, to me, this kind of education as well.
Yeah, this is a long discussion. I often mention it, as my listeners know, I have children too. And for me, the fact that they are still requested to learn by heart Wikipedia, basically, if you want. And then the second thing that they are doing is writing essays, which are just clearly possible to generate anywhere. And you're just wondering at which stage my son will actually go and just generate, because he's still not big enough to figure it out, although I told him a little bit about ChatGPT and other large language models. But, it's a challenge, and it's both sides. I think the teachers, some of them are absolutely unprepared too, and that's the problem.
Yeah, so for instance, to my daughter, I did the classical example of asking, ask, because she was generating images. So I said, ask for an image of doctors treating a patient. Of course, the doctors were male and white. But again, you need to show her. Do you see something wrong in this picture? It took her a while. I mean, because again, you are not aware that this could be. And if you are not careful, then again, you're perpetuating the biases to the next generation.
Of course. And it's all about, the data you input and the ability to understand that probably this data is, first of all, knowing where it comes from, because I think that's also a problem. We just don't necessarily know what those models are trained on exactly. But it also makes me think about the discussion I had, I think more than a year ago, with Professor Jamila Awada about her research at SNT and computer vision, and exactly this whole problem of bias in the data sets.
But if I can be a little bit provocative, the data sets are biased. But the data sets are biased because society is biased. So sometimes we blame artificial intelligence for giving. There are plenty of examples of racist chatbots and biased chatbots and so on. So we like to blame AI, but to me, AI is reproducing society. So maybe we should also blame society. But it seems that it's easier to fix the AI than fixing society.
Oh, this is going to be a very good quote for this discussion. I think very much we're going kind of outside on a general high-level discussion right now. So I think it's good to, before we solve the pub quiz question, I think it's good to look at your 20 years of research, because that's also, I was laughing when we were chatting about it on, I think, LinkedIn, that it's exactly you're as old as the University of Luxembourg, right? So 20 years is already that moment when you start thinking, okay, so where am I going and whatever. So actually, how is it to be a researcher for you after 20 years?
First, I think the reflection should be every 5 years at the most. I think
that's also true, yes.
You need to kind of rethink what you're doing. I think I enter research with a very idealistic view, as everybody. And then you understand that research happens in a context of an organization, and therefore there's a lot of bureaucracy and politics. I still love research. I still love to think solutions to problems, especially I think with say age. Now you try that the problems you think about are more linked to societal problems. I think that when you begin, what you look for, what is the conference taking place, and basically you choose. Not exactly that, but there's a component. You choose the conference based on the location, and you are more excited about the trip than about the research. I think that's fine. Then at some point, I think that my goal now is to make sure that what I do has some purpose. Then maybe I fail. Maybe society is not interested in my solution, but at least that the problem itself that I'm trying to target has some meaning for me. Otherwise, it's not worth.
It's good. It leads me also to the discussion I had with mentors at university. There was an episode about mentorship in academia and exactly kind of guiding people or actually telling them, okay, this is after 5 years, I think it's better if you go somewhere else, right? It's important to have those lampposts, if I can call mentors like that, in your journey, because it's a very special place to be in, and you have to reevaluate quite often, I think.
Yeah, especially because typically everybody wants to be PI, right? So when I was a young postdoc, all my colleagues wanted to be PIs. Well, I think it's one way, but it's not the only way, because as soon as you become a leader of a team, then quite a lot of your work is involving managing people, hiring people, firing people sometimes, growing people. Maybe that's not what you want as a researcher, right? The same as developers. Developers can evolve to project managers and start managing the development teams, or they can become specialized in certain technologies and be the person to go every time there's an issue with that. So researchers could do the same. They can grow up to be team leaders, but that's not the only way. Maybe they would be happier being, the most expert in a specific gene in a specific disease and just focusing and doubling down on that.
Yes, and I think that is valid for basically any kind of, career ladder development. Not everyone needs to be the boss of the bosses, right? And it's good to realize that. It's good you realize it. I mean, not you, Jordi, but in general, people, right? That you just want to stay there, and it's absolutely fine. Good points. And I think it's the moment that we have to switch into the resolution of the pub quiz question rather than the good points and general comments. So if you remember, listeners, the question was about the cars and how many lines of code do they need to operate, right? Cars, did we actually say what type of cars? Is that important or not?
Well, if we could take into account the self-driving car, I think the number could be higher.
Yes,
but I'm just talking about the standard modern cars.
Okay, so how many?
Can you guess? Do you want to give a guess?
No, I am very bad at guessing.
100 millions of lines of code.
That's terribly a lot. And it's also impressive that actually generally they work. I mean, for that many, I don't know what is the average, let's say, standard number of lines of code for a software. I don't know. Is that a lot? From my lay person, it's huge, right?
But again, here we are playing with a number. We're counting everything. So this counts the radio system, but there's also the system for the keeping the line, even optimizing the consumption for electric cars. So there's a lot of different components. But it's true that it's huge, to be honest. It's really, really huge number of lines of code.
So does it mean that if I go to my garage because some lights up right now, these people who are fixing it also have to be able to look at the code or not?
No, but that's like any other appliance in your house. Now, basically, when something gets wrong, the only way to fix it is replacing the full component, right? So my heater system broke down, and basically when the guy came, they took all the electronics and replaced it completely. And mechanics more and more have to do that. They have some kind of diagnostic toolboxes, depending on the model of the car, to point out the potential, what is the component that is failing, and they need to...
Because I have a problem right now in my car that says that the tire pressure is low, and it's not low. So I think something is wrong with the code.
Was this a few years ago, there was this issue with Volkswagen that was masking the pollution, right? And it was a software system that was making the masking. So even in that case, it was really not a mechanical company. It was really the software that was able to fool the evaluator. So
it means that there was some kind of a software engineer that planned the code so that it would be like this? You're not going to comment on this. No comment. Okay, let's leave it there. I think we're getting on some shaky grounds here. So what remains is just to thank you, Jordi, very much for your letting me enter into your world a little bit and talk about all the fascinating things about software and software engineering.
Thanks to you.
And this is it for today. Of course, don't forget to subscribe, to follow us, rate us, please. I think we got some rating recently and even positives. I'm very excited about that. But anyway, if you don't like something, of course, you are more than welcome to write as well and just tell us, suggest guests. And of course, we are present on Instagram, Facebook, LinkedIn, Twitter, X, and everywhere else, websites. Just, yes, check it out, check other episodes. And thank you very much. My name is Hanna Siemaszko, and this was Silax.